so that we'll have something to refer back to. And in fact, whatever we cover, you can always go back to the video later on. That's the beauty of Zoom, because I get to record it, as on Google Meet I can't record the video and you can't review what you have done. Okay, Shakira, why don't you tell me about yourself, like which school you're from, what level are you doing, and just tell me a little bit about yourself.
Okay, my name is Shakira binti Abdullah Iman Fulen. People call me Shakira. I'm from Pusat Tingkatan 6 Belait, and I take chemistry, physics, and maths.
Okay, thank you, Shakira. Next one, Yasmin.
Hello, my name is Yasmin. Yeah, you can call me Yasmin. I'm from MD.
What subjects are you taking, Yasmin?
Biochemistry and maths.
Okay, next one, please. Iza.
My name is Iza. I am from Sekolah Menengah Arab.
Malhab, yeah. Okay. What
Yes.
subject are you taking? Like, as in, what A-level subject are you taking? I know you have the bunch of Arabic subjects, but what A-level subjects are you doing?
Biochem maths.
Okay. Next one. Who's the next one? Afif.
My name's Afif. I'm from Small Hub. I'm taking Biochem Maths.
Okay. Nice to meet you. Next one. Who's the next one? Akila.
Hi, my name is Akila Ibrahim. I am from Pusat Tingkatan 6 Tutong, and I am taking biochemistry and maths.
Okay, so it seems like everyone has the common biochem and maths background, yeah? And looks like Rahiman has just joined us. So Rahiman, hey, good morning. You are late. You're connected to the audio now, so we're just introducing ourselves for the time being. But from next week onwards, when I start the lesson like 5 minutes beforehand, everyone should just join, then no one will get left behind. Okay. All right. Tell us a little bit about yourself, Rahiman. Like, which school are you from, and what A-level subjects are you doing?
My name is Muhammad Rahiman bin Haji Abdul Rahman. I'm from Maktab Science, and my A-level subject is maths, chemistry, and biology.
Okay, so seems like almost everyone is taking chem bio maths except for Shakira, who has physics instead of bio. Okay, no worries. All right, let's get started then. In the middle of this tutorial, we will take I better take attendance first, okay? So if everyone, turn on your video just for the time being, and then you don't have to turn it on throughout, just turn it on now, and then I'll take a quick attendance, as that's what BIBD Alaf actually told us to do. So if everyone turn on your video right now, and then I'll just take a quick attendance. Okay, everyone turn on your video, please. You have to turn on the video, right? This won't be long, it's just for record purpose, okay? We're waiting for everyone else to turn on your video. You guys were informed that you have to keep the video on throughout the whole session, etc., right? But don't worry, I'm not gonna ask you to turn on the video the whole time. But can you please just turn on the video right now, and then we'll just take a quick photo for evidence. Still waiting for Yasmin and Afif. Okay, just one more. Hello, Afif. Come on, we're waiting. We're 5 minutes in already. There are certain things that needs to be covered, yeah? Okay, smile everyone, you're on camera. Oh, Afif camera is off again. Can you please turn on your camera? Okay, smile. I'm taking screenshot now. And again, taking another screenshot. Okay, should be all right, last one. Last one, and then, okay, we're all good to go. All right, so you can turn off your camera. I'll turn off my camera. But whatever I do now, what I just like to inform you is that because it's not one-on-one, different people are from different schools. I assume everyone is upper 6, right? Is anyone from lower 6 here? Like the first year of A-level. Is anyone from lower 6 here?
No.
No one?
No.
Okay, so June AS is coming. I am almost certain that June AS will happen. If they don't close school, June AS will happen. There will be no such thing as SAG from last year, which means you will sit for actual exam. Fingers crossed, okay? If it is a real exam, that means your school might not be doing revision because they are chasing up the A-level syllabus. So you need to prepare your own schedule to join, to prepare your own schedule and set up some sort of timetable. Oh no. Okay, never mind. That should be all right. I hope everyone in this, there are only 6 of you, right? 1, 2, 3, 4, 5, 6. Okay, all 6 are here, right? Okay, all 6 are here. That's all right. I think Arif from BIBD Alaf has just signed in to check that all 6 are here. And all 1, 2, 3, 4, 5, 6. Yeah, all 6 are here. Okay. So back to scheduling. You need to really set up a timetable on your own to revise things on your own. This is a once a week session. You're not going to go from 0 to hero, like in just 1 hour a week kind of session. What I'm here for is to go through a couple of topics, and when you have questions, so feel free to ask. Yeah. So I guess I don't know. I mean, it's quite tricky for me to decide what topic should I go through. Should I go through A2 or should I go through AS topic, right? Because everyone is in upper 6 now, and you're doing different topics, so it's quite tricky. So I thought in preparation for your June AS exam, so it might be quite nice for me to go through topic by topic from AS chemistry. Does anyone have any objection to that? Everyone is
No.
okay? All right, okay, cool. I don't know how good you are with the topic, but I've set up in the Google Classroom, I've set up 2 topics. One is on atomic structure and the other one is on stoichiometry and calculation. So stoichiometry and calculation is to do with everything calculation. So I've only put up the notes and the test paper. So what I'll go through in this 1 hour is to go through a couple of questions, because I assume you're okay with the theory already. Unless there are certain bit of the theory you want me to go through. Is there anything in the theory that you want me to go through? Anyone? No? You okay? All right, okay, if you're okay, let's get started then. You have a choice. Do you want me to go through with atomic structure first? Give me a minute. I don't know why this one is not doing what it's supposed to. Can you see my screen?
Yes.
Okay, cool. The same PDF have been uploaded to the Google Classroom, yeah? So you can access it afterwards. So this was a block test that I will use with A-level students. A block test meaning it covers the entire topic. So this is one of the 2 topics that are there. I'll probably start out with atomic structure first. This is based on the 2023 syllabus, 2022 syllabus, which you are taking the A-level exam this year. So it's entirely based on the new syllabus, okay? So this test was supposed to be done over 1 hour and 30 minutes. What we will have time. Can you mute yourself, Isa, please? Okay. So what you might not have time for is to go through everything today. But what you will have time for is you will have time to actually go through the rest of the paper on your own, and you can submit them on Google Classroom, and I'll have a quick look at what you have done and at least provide you some feedback. Does that seem all right for everyone? Hello? Does that seem all right for everyone?
Yes.
Okay, all right. So what I thought might be nice is for me to go through 1 or 2 questions first, and then I'll ask you guys to try on your own, and then you can, I don't know, I think you can leave a message on the Google Classroom, right? You can take a photo of your answers or whatever, your calculation or whatever, and then you can just leave the answer there and we'll have a quick discussion. Okay, so we'll be using a mixture of these 2 platforms, yeah? So Google Classroom as well as these this thing being screencast on the screen here. Okay, so what do we have here? We have, we need to be better at reading question. MCQ is not easy. Atoms of element X have 6 unpaired electrons, 6 unpaired electrons. The key here is unpaired electrons. If we look at carbons, all of you should have a periodic table next to you. Carbon is in group 4, is in period 2. So it's 1s2, 2s2, 2p2. It's fill up the first shell, and then it fill the second shell, but it doesn't get fully filled. So it's just 2s2 and 2p2. We're just looking at unpaired electron. So we're looking at the 2p2. because the 2s2 is being fully filled already. These are all paired. These are all paired. So when we look at these questions, we draw three boxes, or we draw 3 lines like this, and then we put in the electrons 1 and 2. This represent the 2 electrons in the 2p2. 6 unpaired electron. This is only 2 unpaired electrons, so A cannot be the answer. Everyone okay so far? I mean, I don't know how good people are, so I mean, is this okay so far?
Yes.
Yes.
Can you just shout out if there's anything you don't understand? Yeah? Don't wait for other people. Just stop me. Just shout out when there's something you don't understand. Okay? Because obviously I don't see you. I see the screen. Yeah. So the next one is chromium. So chromium is a special one. As you know, in the periodic table, as you do the transition metals electronic configuration, chromium and copper are very special in terms of configuration. If I start from argon, so square bracket argon. So if I go back to periodic table, if you see this is argon, your chromium is here, your argon is here. So this is 1s2, this is 2s2. There are 6 elements here, so there's 2p6, 2 because the p block start from 2p, 6, and then 3s2, and then 3p6. So there's argon in the square bracket. After 3s2, this is the 4th shell, 1, 2, 3, and 4. This is 4s1, 4s2, so 4s2, and then 3d1, 3d2, 3d3, 3d4, 4s2, 3d4, d1, d2, d3, d4. So chromium there, you would think that chromium is argon, and then 4s2, 3d4, and that is actually wrong. That is actually wrong, and you know that because chromium and copper have a very special electronic configuration. What it should be instead is to minimize this repulsion. This is a repulsion because you pair them up in the same orbital. So what happened with chromium is it will just promote one of the electrons. They become 4s1, and they become 3d5. So what you have is like this energy level. So 4s1, and then the 3d, they are all of the same energy. So what happened is 1, 2, 3, 4, 5. So altogether you got 1, 2, 3, 4, 5, 6. You got 6 unpaired electrons, and that is the reason why B is the answer and not A, and definitely not the rest of them. Okay, happy so far? Okay, I guess that's all right. So if you try, can each of you try the electronic configuration of iron? Iron from the periodic table, iron, Fe. So I'm just going to go to the periodic table, and you can see iron. Hope you can see iron is in the first row of the transition metals, somewhere in here, iron. So iron is here. I'm going to ask everyone to do it, but I'm just going to ask someone to shout out the answer. But everyone, please do it, yeah? And then I'll ask you randomly. So to get the configuration, you should be able to do this in 1 minute. Now, actually 10 seconds, because you have 4 choices that you needed to go through in 1 minute. So you need to be able to get the configuration in 10 seconds. Okay, Rahiman, why don't you shout out to me? How do you get the configuration for iron?
Argon.
Argon, okay.
3d6,
Okay.
4s2.
Okay, so he started from argon. Essentially, after argon, you should really fill in the 4s2, because after argon, then you fill 4s2 first before 3d, you see? So to get here, you're playing the snake ladder game. So you have argon. After argon, then you go this one, potassium and calcium first. So there's 4s2, and then 3d berapa tadi?
6.
1, 2, 3, 4, 5, 6. So there's 3d6. Okay, that is iron atom. So obviously, you know, it looks like there is 6 there, but there is actually 1, 2, 3, 4, 5. How many unpaired electrons are there, Akila? So this is the 3D. If you put in the electrons, how many unpaired electrons are there? Are you there, Akila? Hello, Akila, are you there? Akila? Probably not then. Okay, Yasmin? Yasmin? How many unpaired electrons are there when you have 3d6? Are you still with me, Yasmin?
So
our
first target is the 12
4, 4, 3, 1, 2, 3.
Okay, so 1,
6.
2, 3, 4, 5, 6. So altogether, you have 1, 2, 3, 4. Okay, so there are 4 unpaired electrons.
Or
Hang on, I just need to mute someone. Afif, can you mute yourself? Because there's someone who hasn't muted themselves and it's a bit disturbing in the background. Okay, so there are 4, 1, 2, 3, 4. There are 4 unpaired electrons in the iron atom. Despite it looking like 3d6, there's actually 4 unpaired electrons because the question is asking on unpaired electrons. This question is very, very important because I'm going to ask you something now. How about when you go to Fe+? What is the electronic configuration? Which one do you lose from? Do you lose from the 4s first or do you lose from the 3d first? Let's ask someone else. I don't know. Afif, ready? Afif. Which one do you lose from? This one means you lose 1 electron. So where do you lose it from? Do you lose it from 4s or do you lose it from 3d?
4s.
4s is correct. So what is this going to be? It's going to be argon, and then
4s1, 3d6.
that is correct. And then when you go to Fe2+, you're going to lose the other one from the 4s. You're going to be 4s0 and 3d6. So typically we don't show that. Okay. The most difficult thing really is people thought, you fill 4s before 3d, but you have to lose from 4s before 3d also when you form the ion. So be very careful about electronic configuration of the transition metal ion. Yeah. Okay, let's go back to the questions. So we already gotten that first question. This second question is a counting particle kind of thing. It's atomic structure. More protons than electrons, more protons than electrons, and more protons than neutrons, more protons than neutrons. You have this configuration that looks like this. This is a hydrogen atom, but it is what is this number at the bottom? What does it tell you, Yasmin? Actually, Isa, what does this number at the bottom tell you?
Proton number.
Proton number. What is the other name for proton number, Isa? Proton number has another name.
Atomic number.
Atomic number. So your
Atomic
periodic table
number.
show you atomic number or proton number. What is this number on top, Isa?
Atomic mass.
That is wrong. That is what your periodic table shows you. Your periodic table shows you in the middle, and it labels this as relative atomic mass. But then when you are in this nuclide notation where they are to the far left, these are never the relative atomic mass. These are exact mass. These are called mass number, or you call it. Oh no, what happened? Did someone get disconnected? Hang on. What is going on? Okay, can you see my screen, everyone? I have no idea what actually happened there. You can see my screen, all right, yeah? Okay, so that is mass number or nucleon number there. So that is not relative atomic mass because this is the average, whereas this is the actual mass number or nuclear number for that particular isotope there. Okay, so looking at that, we have deuterium, which is that thing here. So we have 3 of that and 1 of oxygen and a +1. The first thing you do with this kind of question is you got to identify protons, electrons, and neutrons. Proton have a +1 relative charge. Electron has a -1 relative charge. Neutron is just neutron, is uncharged. So can you count how many proton does all of these have? So you have 3 deuterium. Each one has 1 proton. So you have 3 of them. So you must have 3 times 1, which is 3 proton. And then oxygen has 8 protons. So 3 times 1 is 3 plus 8 is 11. Should be no problem getting 11, I think. Okay. All right. Now the electrons. So the whole molecule is D3O, but the whole thing has a +1. +1 means you have lost 1 electron. When you lose 1 electron, you're going to have 10. The neutron is the worst bit of all, because if you have 1 deuterium, you have that. You have 1 neutron. 2 minus 1 is going to be 1 neutron, because nucleon is basically the protons and the neutrons, and you take away the proton, so you're just left with 1 neutron there. So 1 deuterium has 1 neutron. You have 3 deuterium, so 3 neutron. For the oxygen from your periodic table, which I guess they don't tell you, but 16 and 8. So 16 minus 8 is actually 8 neutron. So you have 3 plus 8 neutron, which is going to be 11 neutron. Here we can see we want more protons than electrons, more protons than electrons. The proton electrons, yes, proton more than electrons, more protons than neutrons, more protons than neutrons. We can see that A is definitely not the answer already. Okay, happy? Now I'm gonna ask each of you, okay? Try and do the protons, electrons, and neutrons. Okay, I give you 1 minute and you try and do for B, C, and D on a piece of paper. You're supposed to be scribbling all over the place, yeah, when you do exam question, not just reading. Reading never just help. Okay, so give yourself like 1 minute to go through all the proton, electrons, and neutrons. And then I'll ask someone to tell me and share with me. Who else has an answer? Let's see. 1, 2, 3, 4, 5. Shakira, how many protons are there in this H3O plus?
9.
9 is wrong. If you think about it, you have hydrogen, right? So you have 3 hydrogen. Each hydrogen has 1 proton. Each hydrogen has 1 proton. You have 3 hydrogen, so that is 1 times 3. How many protons does oxygen have from your periodic table? Proton number or atomic number tells you how many protons they have. So how many protons does oxygen have? Oxygen is element number 8. So how many protons does oxygen have? Do you know that oxygen is element number 8 in the periodic table? Let me show you oxygen, yeah? Okay, so oxygen is here. Oxygen is element number 8 in the periodic table. So we know that oxygen will have 8 protons. So that is actually 11 protons, okay? Why don't you continue on this, Shakira? How many electrons does H3O plus have?
10.
Yep, you always count the proton correctly first. Then you assume that it's not charged. Then you think about the plus 1, which you take away 1, and then you have 10 electrons. Well, you continue the last one, Shakira. How many neutrons does this one have?
11.
11 is wrong because this is D. D is the heavy isotope. But when you have hydrogen H, what you have is just H11. This is called hydrogen 1. This is hydrogen 2. This is isotope, remember? They specifically give you that. So what you have then is hydrogen 1 does not have any neutron. 1 minus 1, 0 neutron. 0 neutron there. If you don't have any neutron, that means the neutron comes from the oxygen. You have 1 of it, so you only have 8 neutron there. Well, let's check our thing here before we actually waste more time and do for the rest of them. We have more protons than electrons. We have more protons than neutrons. So we already got our answer. In a real exam, we don't care about doing for the rest of them. We care about getting the answer and then moving on. You have 1 minute for every single MCQ. You get that? Everyone okay, yeah? All right, okay.
Yes.
I'm going to skip some of these questions because you're supposed to go through some of these on your own. What I'd like to do is just go through more and more examples. For example, let's go through question 8. Okay, question 8. Why don't you spend 1 minute on this, and then I'm going to ask someone to think about this. Someone to tell me about this. Actually, Akila, what do you think for the question number 8? So what's the first thing you would do when you see a question like this? What's the first thing you should do? Hello, Akila. What's the first thing you should do?
Highlight the key points on the question.
Okay, I guess you have an atom of this, you have an atom of this, okay? Now you have that. Now these are the symbol of the elements. What is the next thing you should do? You need to find information on this, and this, right? So what should you do? You should go to the periodic table and you should tell me the proton number. Can you tell me the proton number of helium and hydrogen, please?
Proton
Do you have a
number for proton number for helium is 2.
Yeah.
and for hydrogen is 1.
Okay, now we gotten the isotope. The information is complete. So the next thing you do is proton, electron, neutron. Always like this. This type of question always like this. Okay. Okay. Why don't you continue, Akila? Okay. Proton for helium. What is this number I fill in here? So we're gonna go across. Yeah. Go on. What do I fill in here?
2. Proton
Okay.
number for
Because
helium.
once you write this information, you no longer go to the periodic table. You should just look at this information here. Proton number, atomic number. This is mass number, or what you call nucleon number, okay? So the proton number for hydrogen there is definitely just 1. Now you got to tell me about the electrons, Akila. How many electrons does this helium atom has?
2 electrons.
2. And how about the electrons here?
1 electrons.
So the number of electrons must be equal to the number of protons because you have atom. Atom is uncharged, all right? So the neutron, last thing you should do. Akila, continue.
0.
That will be wrong because you have 4 nucleon. Inside your nucleus, you will have 2 protons, but you also have 2 neutrons. So you get 2 plus 2, which is 4 nucleon. Nucleons refer to everything inside the nucleus. You have 4 of them. So there should be 4 minus 2, which is 2 neutrons. 4 minus 2 there. Okay, to get the number of neutrons, you do the mass number or the nuclear number minus the proton number. That one is your O-level curriculum. It's not 1, it's 2. So based on all of this information, let's check what is the same. You say highlight information, right? What is the same? Number of electrons. Are they the same? They are not the same. Cross this out. Number of protons. This is the one that I can cross out definitely because they are different elements. If you are different elements, you can never have the same number of protons because different identity, different element, different proton number can never be the same. Okay, I can cross these 2 out. Number of neutrons. Number of neutrons are the same here. B is definitely the answer. Relative atomic mass is not necessarily the same because, well, if you look at the mass number, it's different. But relative atomic mass has a specific definition in your notes from your school lessons. You will know that this is to do with the average mass of blah, 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 blah. Okay. Well, anyway, let me just double check. I think Akila, you should mute yourself. I'm going to mute you. Okay. All right, next one. This is to do with ionization energy. All right, so before I go through this MCQ, I'll just jump straight to one of these structured questions because the structured questions is usually better in terms of explaining things in greater detail. So this is a question on ionization energy. So before we go through ionization energy, we need to recap a couple of things first. All right, so ionization energy, the first ionization energy. If I write an equation, you gotta always write the equation first. Equation is very, very important. Okay. Who else haven't answered a question? Afif. Did I ask Afif or Rahim? Never mind. Afif. If I have element X, okay, X, can you tell me how would the equation look like if I ask you to write first ionization energy, the equation?
X plus 1.
X plus 1. You mean like this? Or you mean the charge? Do you mean the charge or do you mean the charge? Okay. So what does it become? What does this go to? Will the rest of you try on your paper and then we'll discuss this? Yeah, equation, right? So what does it become of it? Anything, Afif? First ionization energy.
X plus 1 plus E minus.
And then? Anything? Are you okay, Afif? Because if this is the rate that you go through in exam, you're gonna struggle, okay? What does this give you?
X.
Give you X, okay? And I'll tell you that is absolutely wrong because the first thing you know is ionization. Ionization here refers to losing electron, lose electron. What have you done? You have done gaining electron. That is absolutely wrong, okay? You will get 0 mark, okay? The correct equation will be from X gaseous, and then you go to form X plus gaseous plus electron. What have I shown? I have shown the loss of electrons. When you do plus electrons on the right-hand side, it means you lose electron. Ionization means lose electron. The first mean you are forming something which is +1. And the stat symbols are required, absolutely required in the definition. By writing this thing here, when you write this thing, you can get the 3-mark definition. It's usually a 3 marks definition. I know it's not the question here, but when the question comes, you just never know what hit you until you know how to, write down the definition. Okay, everyone listen, yeah? Whenever a question asks you to define first ionization energy or second ionization energy, you always write down the equation. Always write down the correct equations. Make sure the stat symbol, everything is gaseous. Make sure you always show losing 1 electron there. Okay, so the first ionization energy is defined as, okay, energy required. So this is a very important thing. If you look in your data booklet, they will show you in kilojoule per mole. This is per mole. That's why we have to talk about 1 mole, 1 mole, 1 mole. In the data booklet, the value is given as per mole. So it's the energy required to remove 1 mole of electrons. So different textbooks, different teachers, different people, they will have slightly different definition. But everyone will need to have the exact same point. The point must be the same, the concept must be the same, but the way you express the concept can change. But everything revolves around this equation. If you're okay with English, you can come up with your own words as well. As long as you still have 1 mole of electrons, 1 mole of electrons, you remove it because you're losing it. Where are you from? From 1 mole. From 1 mole of gaseous atom. Why do I focus on gaseous atom? Because this is gaseous and this must be atom. It cannot be molecule. It must be atom with no molecule at all, and it must be gaseous. That's why the stat symbols are required. If you look at any textbooks, any marking schemes, any teachers, they will tell you the gaseous atom is required, the 1 mole is required because of the unit per mole there. And then what are you forming? To form 1 mole of gaseous ion. But that is not complete. This is an ion, this is a +1 charge. So this gaseous ion is with +1 charge. Now, based on that definition, this is basically putting this into words. Define first ionization energy. Write the equation first, but you will not get full mark like that. You need to define it in words. You are removing 1 mole of electrons from 1 mole of gaseous atom to form 1 mole of gaseous ion with a +1 charge. Now I'm gonna ask, I don't know, Rahiman, why don't you tell me the equation for second ionization energy? Second ionization energy. What is the equation if I use X again?
X charge 2 plus arrow X plus E minus.
Okay, now I'm gonna ask you something. Is this complete?
Gaseous state.
Okay, and I'm gonna tell you something. You got this wrong. You know why?
Two.
On the left-hand side, you have +2. Here you have +1. Here you have -1. +1 and -1 will give you 0. So +2 does not equal to 0. You are losing electrons. As you lose electrons, your charge becomes more positive. Your mistake was here. This was your mistake. Okay, so it should have been X plus going to X2 plus. Then you have +2. Then you have +1 on the left and +1 on the right, +2 -1. You should know how to count charges. Those are from your O-level days, yeah? Okay, everyone, can you see that, Afif? No, sorry, siapa tadi? Rahiman, can you see that?
Yes.
You sure? Okay. You see, it's a progressive kind of thing, yeah? From the atom, become X plus 1. And then X plus 1, lose another electrons. And then I can go further. Third ionization energy is going to be X2 plus, become X3 plus. Third ionization energy means I become the X3 plus, and then I lose 1 electron. Okay, and so on and so forth. Now, my question for you, okay, Rahiman, based on your equation, everyone try this as well. Based on the equation, look at the equation, define second ionization energy. Look at the equation and define it in your own words. Okay, tell me, it's a 3-mark definition. Go on, Rahiman. What can you say by looking at the equation? So second ionization energy.
Energy required to remove 1 mole of electrons from 1 mole of ions, gaseous
1 mole of
ions.
gaseous ion. You forget the +1 charge. 1 mole of gaseous ion with a +1 charge. Okay. All right.
Okay.
Continue.
To form 1 mole of gaseous ions with 2+ charge.
That's it. Okay. So I mean that is essentially the full definition. There's no teacher or no CIE examiner who can fault you for that. Different textbook, they will say singly charged gaseous ion is the same as gaseous ion with a +1 charge. Singly charged gaseous ion is the same as gaseous ion with a +1 charge. I just like to use simpler words, easier to remember. Write your equation, get it right, put it in your own words. Okay, just make sure you don't forget the gaseous. Just make sure you don't forget that the 1 mole kind of thing. So here is to form 1 mole of gaseous ion with a +2 charge. Okay, I tell you what, I'll send this PDF to you. I'll put it in a Google Classroom afterwards as well. But as you go along this tutorial, so learn to write some equations and think about what you can do on your own as well. Yeah. Okay, everyone, you should be able to define first and second ionization energy now. Yeah. Now, in terms of explaining trends, ionization energy, how in the world do we explain the trend? This is down a group, and then this is successive ionization energy, and there's supposed to be another one which is across a period. So I think I better go through a couple of concepts first, okay? Explaining ionization energy. So this is a good recap for your periodicity chemistry in order to tackle this kind of essay-based question, yeah? So in order to explain this, you think about ionization energy just now was to, if I think about first ionization energy, this is gas going to X plus gas plus electrons. So what we're doing is we're removing the electrons from their shell. We're removing the electron from the outermost shell, obviously, okay? So when you go across a period, so we're going horizontally, going across a period, is it getting harder or is it getting easier to remove the electrons across a period? Well, the first thing you do is you talk about the number of protons. So when the number of protons in the nucleus across a period, you are increasing the proton number 1 by 1. So proton number increases, number of proton increases, nuclear charge. Nuclear charge is going to be positive. It contains the protons and the neutrons. So the nuclear charge from the protons is going to get more and more positive, more and more positive. So the electrons are in the shells, but then they are in the same shell because filling in the same shell, shielding is roughly constant. Some books or some teacher will say that it's insignificant, or you can say negligible, because the electrons continuously fill in the same shell. So the electron just keep on fill in the same shell. And that's why when you are in the cinema, you are sitting in the same row, whatever is in front of you is blocking your view roughly about the same. There's the concept of shielding. Last but not least, this is the net effect. This is the net effect. We call it the effective nuclear charge. Some books or some teachers, again, because you come from different school, they might use different term, but they all revolve around between this and this. So this is blocking your view. You are electrons in the shell. You imagine your first shell, your second shell, and then if you are here, you are being blocked by the electrons inside here because you're in the second shell. So second shell electrons is being shielded by the first shell electrons. The further you are away from the nucleus, the more shielded you are. Nucleus has a net positive charge due to the nuclear charge from the protons. Electrons have a negative charge and they are attracted to the protons in the nucleus. And if you think about the attraction, if the attraction is stronger, then it's going to pull it closer together. Your size is going to decrease. In fact, when I pull it closer together, your size will get smaller. But when I pull it closer together, it's because they are more attracted to the nucleus, the protons in the nucleus. That means it's harder to remove the valence electron as well. So they are all related. So what happened to this effective nuclear charge? It will get stronger. The thing that is blocking you is about the same, but you have stronger nuclear charge. This minus this, I don't care about actual value. I care about the qualitative sense of it. It becomes stronger attraction between the valence electrons and the nucleus and the protons in the nucleus. So this thing will give rise to a couple of things. First of all, your size will decrease. This is called atomic radius. This is killing 3 birds with 1 stone. Yeah, atomic radius will decrease, smaller in size, because you are pulling your electrons. Your electrons are being pulled closer. They are more attracted to the nucleus. So the whole thing is pulled closer together. So your size is going to decrease. Atomic radius will decrease. Number 1. Number 2, if I pull the electron closer together, the electrons are held more tightly. They are more tightly held. If they are more tightly held, it is harder to remove, meaning to ionize. That is why first ionization energy generally increases. It gets harder to remove the outer shell electrons because they get pulled closer to the nucleus. They get more attracted as a result of these, and the overall net effect. Last but not least, the same explanation also explains electronegativity. So the question can ask you, explain the trend in atomic radius, explain the trend in first ionization energy, explain the trend in electronegativity. The 3 reasons are the same. You just need to change your essay. You just need to change the final point to fit whatever the question is asking. But the same idea, they all come from the same idea. Okay. Electronegativity. How strong is the ability of an atom to pull bonding electrons towards itself? When you are bonding X and Y, there will be a winner in this tug of war when they have different electronegativity. Something will pull it closer to itself, and therefore, as a result of that, that is due to these 3 factors. The most electronegative atom is fluorine. So when your effective nuclear charge increases, your electronegativity increases. You can think about fluorine being the most electronegative atom, and the electronegativity decreases that way, which means going this way, electronegativity increases. And guess what? We are talking about across a period, electronegativity increases because factor, and factor. 3 marks essay, usually to explain atomic radius, to explain the general trend in first ionization energy, the general trend in electronegativity as well. Okay, so that was just across a period. Now going down the group, we will just spend another, 10 more minutes on this. Yeah, this is just going through the concept, which is very, very important. And once you have the concept, you can do a lot of things. Down the group, you are filling in more and more shells. So if you imagine this is the first shell, the second shell, and then I have the third shell. So second shell, and then the third shell. So the most important thing going down the group is I got to talk about the same thing. Down the group, what do I have? I have my number of shells. Oops, sorry. I should talk about proton first. The number of protons will increase. So obviously, nuclear charge will increase. So the nucleus become more positive. That is a given. But then the key factor going down the group is not to do with the number of protons, but actually to do with the number of shells. The number of filled shell increase. You get more and more electron shells, and therefore your shielding is getting more stronger. You are being blocked. You're sitting further and further away from the cinema central view. So your vision is getting blurrer. Okay, and therefore you don't feel the attraction to the protons in the nucleus that strong. So the shielding is an important factor. So overall, this is the net effective nuclear charge, because effectively, as a result of shielding, which block a lot of your nuclear charge, your effective nuclear charge will decrease. Now, this thing does not explain size. The size increases because you have more shells. You definitely have more shells, so size will increase. This is atomic radius. But then, how easy it is to remove the outer shell electrons comes down to this. How easy it is to remove the outer shell electrons, that is your first ionization energy, decreases down the group because it becomes easier for you to lose the outer shell electrons. As the outer shell electrons get further and further away, they get a lot more shielded and therefore much easier to remove since they are less attracted to the nucleus. This also explains electronegativity decreasing down the group because, as you know, fluorine is the most electronegative. Going down the group, electronegativity will decrease as well. So you're killing 2 birds with 1 stone using the same factor there. All right. The next thing is the case study. This is the specific drop. These are the specific drop in the first ionization energy. Can you remind me? Let's think about this. Yasmin, are you still there? Can you tell me where would be the specific drop in the first ionization energy across a period? Are you there, Yasmin?
Yes.
Okay, so where will be the specific drop in the first ionization energy across any period? Like let's say across third period, for example. So where will between where and where is the drop?
Calcium and gallium.
Nope. Calcium is in period number 4.
Eh.
Calcium is in period number 4. We're looking at third period, which is your case study.
Aluminium.
Okay, magnesium and aluminium. And where's the second drop?
Second drop is
Don't know. Not sure.
no, not sure.
It's all right. The second drop is always between group
Phosphorus, sulfur.
phosphorus and sulfur, group 15 and group 16. Okay, so you don't really remember the elements per se, but you remember the group number, because the group number is very important to remember like that. You forget because you're not linking it to the general concept that you have to remember. The most important thing that you need to remember, however, is the idea of subshells. So this is filling in the subshell. So the subshell shielding. What are the subshell? The S versus the P. Here, for the second drop, is between the paired electron repulsion. Our brain is engineered in such a way that there's no way we'll remember so many things, especially for those in the Arabic stream. Yeah, you have so many subjects to remember. How are you going to remember a few more things? You have to try and make things easy for yourself. Remember the trigger, and once you have the trigger, you can write your own words. Okay, the subshell shielding. Let me just give you a general idea of what I mean by the subshell shielding. Yeah. So when you have group, oh no, sorry, where is it? Okay, when you have group 2 and group 13, so here you have like magnesium, which is 1s2, 2s2, 2p6, 3s2, and then aluminium, which is 1s2, 2s2, 2p6, 3s2, 3p1. So the difference is going from the S to filling in the P subshell. If I draw an S orbital like that, and then I draw a P orbital, which is like that. So if there's my 3s and that's my 3p, remember that orbitals are basically a region of space where you're most likely to find the electrons. So your electrons in the S is always around here. They're always moving. Now I use the green one. Your electrons, when your electron is moving around here, can you see that in the green region, they are more shielded? So they are more shielded and they are further away from the nucleus. Not the one here, but when the electrons are moving somewhere around that region, they are shielded by the electron in the S subshell, and they are further away from the center, which is the nucleus. So they are more shielded. So the electrons in the P subshell, they are more shielded, further away from the nucleus. Okay, and there's the reason. There's the reason why it is slightly easier to remove the electron in the P subshell. Slightly easier to remove because on average, if you can draw this diagram, you can see what's going on. More shielded, further away from the nucleus, easier to remove, slightly easier to remove. That is why you get your first drop when you go from the S subshell to filling in the P subshell. Because here you are removing from the P subshell, here you're removing from the S subshell. These are slightly more shielded. They are more further away from the nucleus, easier to remove. That's why you get a slight drop in your first ionization energy. The second drop is slightly harder to understand, but this is group 15 and this is group 16. If I go to my periodic table, this is actually P1, P2, P3, P4, P5, P6. There are 6 elements that fill across the P block. P1, P2, P3, P4, P5, P6. This is S1 and S2. This is D1 all the way to D10. There are 2 electrons that you can fill in one S subshell. There are 6 electrons to fill in the 3 of the P subshell because you can pair them up afterward. There are 5 of the D orbitals, which you can fill 10 electrons across. Group 15 is always P3. Group 16 is always P4, not P6. P6 is fully filled noble gases already. So what is so special about the P3 and P4? The P3 and the P4 is basically unpaired electron first. This is Hahn's first rule. Maximize your parallel spin first. The second rule basically is pair them up. The fourth one has to be paired up. When they are paired up, this is your reason. This is your reason. Remember just now, you have your p orbital, which are like this, and like this. So x, y, and z direction, three-dimensional. You call this dumbbell shape. So what happened then is you have to pair them up. These are electrons, but at least they are orienting themselves in the opposite, in their own directions. So they do repel. Electrons do repel, same charge. But here, at least each of them is occupying their own room. Imagine if you put someone else in your room, they are of the same charge, they hate each other, and you're putting two electrons in the same room. So now these are what you call paired electrons, and that paired electrons will repel more than unpaired electrons. Just this one sentence alone will give you the 1 mark, okay? And this is the very reasons why it is slightly easier to remove. Therefore, slightly easier to remove, because you are removing an unfavorable repulsion between the paired electrons compared to the unpaired electrons. So to summarize, you should be able to sketch this, yeah? All of you should be able to sketch this if you want to score well for your A-level. Generally, it should go up, general. This is general trend across a period for first ionization energy. But we know in reality, it will go up, and then it will come down, and then it will go up, and then it will come down, and then it will go up, and it will come all the way down. So here, if I look at this is group 1. Oops, we use the Latin numeral, and this is the new group 1. This is new shell. This new shell is further away from the nucleus. And when you are further away from the nucleus like that, and you are also more shielded, significantly more shielded as you are filling in the new shell. So that thing here is between the S and the P. So that is group 2, that is group 13. This is between the P3 and the P4. So P3 and P4. So there's group 15. Oops, sorry, there's group 16, and there's group 15. And this highest one is going to be group 18, the noble gases there. All right. So this kind of thing, it doesn't matter how many times someone tell you, unless you actually, draw it down on paper, you're not going to become very good at that. Okay. So some of these test questions will actually revolve around this kind of concept. For example, this one, decreasing down the group. As you could see, this decreased down the group, this decreased down the group, this decreased down the group. I already explained it previously. For 3 marks and a lot of lines, you should really be able to explain the nuclear charge. So what happened to the number of protons in the nuclear charge? You must talk about shielding and the number of shells, because obviously going down the group, you have more shells, and you must talk about the overall net effect. So some books might not talk about effective nuclear charge, but they definitely talk about the net effect of this and that. And therefore, it becomes easier to remove the valence electron. This next one is the last thing I'll talk about in the time that I have today. This is called successive ionization energy. Because these are group 2 elements, if you think about magnesium, so there's 1s2, 2s2, 2p6, 3s2. So I can do this on my screen very easily. When I lose 1 electron and when I lose 2 electrons, so it's going to become 3s1, and then it's going to become 3s0. That means like that. And then it's going to be, the next one is going to become 2p5, like that. If you think about your first, your second, and your third ionization energy, this is first ionization energy. Remove from that. Your second ionization energy, remove from the S subshell as well, remove from there, the black color one. And now the pink color one, this is the third ionization energy. You remove from the inner shell. So you need to remove from the inner shell. The electrons are being removed from the inner shell. And if you think about the shell number 2 and shell number 3, shell number 2 is definitely further away from the nucleus, closer to the nucleus. Inner shell is closer to the nucleus. And when it is closer to the nucleus, it is going to be less shielded, because you are closer to the nucleus, you are less blocked by something else. And therefore, it experiences much, much stronger net attraction. So you call it the net attraction, or you call it the net effective nuclear charge, harder much harder to remove. And this is the same thing for like a group 3 element. If you look in your data booklet, so this is group 2. So the third one is difficult to remove because it's removed from the inner shell. If I go to my data booklet will show me a bunch of ionization energy. If I look for lithium, lithium is in group 1. So it's got 1 valence electron. So the first one is whatever it is, but the second one is very difficult to remove. You see this? Very difficult to remove. When it's very difficult to remove, why is it very difficult to remove? Because the first one is removed from the outer shell. The second one must be removed from the inner shell because you lost your one and only valence electron since you're group 1. So the biggest jump is between the first and the second. And because your second one is very difficult to be removed, so that means the second one is removed from the inner shell. That means you only have 1 electron in the outer shell. That means it must be in group 1. So you are going backward, reverse engineer the process, okay? So for instance, I'm just gonna go, okay? First, second, third, fourth, okay? First, second, third, and fourth. So let's have a look at, I'm trying to find something which is quite obvious, okay? So this is the first, this is the second, this is the third, and this is the fourth. Okay, who gets to answer the last bit of question? Isa, are you still there?
Yes.
All right, Isa, where is the biggest jump? Where do you see is the biggest jump? Between where and where? So these are ionization energy, right? Where do you see is the biggest jump?
Second and third.
So the biggest jump is between the second and the third. So which one is very difficult to remove? The second or the third?
The second one.
But the biggest jump is between the second and the third. So suddenly there's a big jump. Suddenly it requires a lot more energy to remove this. So this is the one that is more difficult to remove. Suddenly become more difficult to remove. Not the second one, but the third one. Careful, yeah? The third one become very difficult to remove there. Okay, so this is removing the third electron. This is removing the third electrons. So this is removed from the inner shell because suddenly it becomes very difficult to remove. Very difficult to remove. So that means you remove that from the inner shell. So that means how many outer shell electrons do you have? So you removed 1 electron, remove another electron. So this one is very difficult to remove. The third one is very difficult to remove. So how many outer shell electrons do you have? 1, 2. So you must have 2 outer shell electrons. If you have 2 outer shell electrons, what group are you in?
2.
2. And let me have a look. There you go. That is element number 12. That is magnesium. This is how we do when you see this kind of question, where it gives you just the value without the element. This is what you do. You think about where is the biggest jump. And then the one which is suddenly very difficult to remove must be from the inner shell, closer to the nucleus, more attracted to the nucleus, therefore less shielded, which means this is not included. This must be the outer shell. If you look at the next one, suddenly the biggest jump is here. So you have 1, 2, and 3, which is why you are a group 13 aluminium with 3 outer shell electrons. Okay, I think I'll just stop here. I haven't really talked too much about the test paper, the questions, and I think it can be done in 1 hour. So, you know, if you finish that, then we'll discuss that for next week. Okay, and if you finish it, you just dump it in the, I don't know, we'll find a way for you to dump the work somewhere. But yeah, I'll let you know sometime soon. Okay, if you got questions, feel free to just pause it on the Google Classroom. Yeah, this annotated PDF, I'll upload it to the Google Classroom later on. But I think before we leave, let's just take another photo because I think that's what BIBD Alaf wants. So if you just turn on your camera again, and I will quickly take a screenshot of your photo, and then we'll just call it a day here. Thank you, everyone. Can you just turn on your video very quickly? You need a break, right, everyone? So come on, turn on your video very quickly. I'll take a quick photo and then we'll just leave it here for today. Okay, just waiting for Yasmin then. I don't know, I hope that was okay, everyone. Was it too fast, too slow? Too much? It's only 1 topic, right? You have a lot more topics. All right, last one, okay. All right, all good, okay. I'll leave it there for today. I'll stop recording. I'll share the recording later on, all right? Okay, bye everyone.
Thank you, sir.
Okay,